we know that work equals force times displacement times cos theta. And earlier we have seen that the unit of work is Newton, the unit of distance is, SI unit for distance is meter, and cos theta is just a ratio between two sides, so it's a dimensionless quantity, so you can just leave that out, it doesn't have any meaning. And we have said that work is measured in Newton meter. Okay, so this was the earlier unit that we had seen for work. What we have done in the previous class is we have derived a way to measure the gravitational potential energy possessed by an object which is at a certain height h above the ground. How did we do that? We said consider the object at the ground level. Somehow when I draw it in the lower position, I always draw it smaller than the higher position. And when you lift this object from this position to that position, you have to apply a minimum force which is equal to and opposite in direction to the force of gravity acting on that object. So you have mg in this direction and you have to apply mg in that direction, and this will be equal to your support force. Now if you look at the equation for work, F times d times cos theta, we figured out that substituting for those things, the force is mg, the distance moved is h, and the theta is 0 degrees, so cos 0 degrees is 1. So we get that the work done in lifting an object from this to that height is m times g times h. Now using this equation, if we do a dimensional analysis, what quantity will we obtain? Okay, so in this situation, if you take the mass of the object to be 100 grams, and therefore mg approximately equal to 1 Newton, and the distance that the object has been raised by h as 1 meter. So you're lifting an object approximately the size of an apple by a distance of about 1 meter. Okay, so let me show you. This is a half a meter scale. Okay, so when it is put straight up, that's the distance that you would have to raise it in order to raise it up by half a meter. So twice of this. So you raise an apple twice of that distance. Then what will be the work that has been done? The work done will be mg, which is equal to 1 Newton, times the height, which is 1 meter. Okay. Now the work that you would have done when you lift an object of weight 1 Newton by a height of 1 meter, of course against gravity, is, because this is 1 and this is 1, it would also have to be 1 Newton meter, of course, from this, but Newton meter, Newton times meter, is given a special symbol Joule. Okay, so we introduce a new unit for work done, which is Joule, abbreviated to capital J. Okay, so we can make the statement that when an object is raised by a distance of 1 meter by applying a force of 1 Newton on it, continuous force of 1 Newton on it, then the work done on that object is 1 Joule. And that's in honor of a scientist called James Joule. You can look him up if you like. Um, he did some work on thermodynamics and other things. This was still at a time when they were called as natural philosophers, so you can't call him a physicist. I think he did some contributions in chemistry also. So that introduces the SI unit for work done, which is Joule. Newton obviously, sorry, 1 Joule obviously is not a great deal of work. Okay, anybody can lift an apple by a distance of 1 meter without breaking a sweat. So typically we talk in terms of much larger multiples of the Joule. So like in every other case, you have the kilojoule, which is 1000 joules. You have the megajoules, which is the 10 power 6 joules, and then gigajoules, which is 10 power 9 joules. All you need to remember is the kilo, mega and giga and what they represent. Everything else will be a repetition of the same thing. But remember that this is a kind of typical kind of question that could be asked in the board examination. You could be asked to write down how many joules make 1 megajoule or 1 kilojoule. It will be a 1 mark question, so you just have to write the appropriate number with the units and then you score the mark. So it's an easy mark to take. Don't ignore that. Make sure you understand how you do that particular calculation. I mean, it's not like a calculation, you just have to remember it and take it out. So the next thing is, of course, the CGS units. Okay, so this is another favorite of the board, asking questions in terms of conversions from SI unit to CGS unit. For every quantity that we consider as far as the ICSE syllabus is concerned, you also are expected to know, wherever it is mentioned in the syllabus explicitly, it's CGS unit. Not only should you know the CGS unit, you should know how to do the conversion between the CGS unit and the SI unit also. They really love asking these questions and they ask at least 1 or 2 questions based on that. One in the compulsory section and usually one more in the optional section, in the second section. So please make sure that you understand these, what do they call it, relationships well, and that you are able to derive or show the conversions. Okay, so the CGS unit is an old archaic unit, the unit for work. CGS of course stands for centimeter gram second, which is the measures respectively of length, mass and time. So in the CGS unit, the unit for force, so I'm using the same equation, work is equal to force times displacement times cos theta. So force is measured in a unit called erg. Okay, you can look up what an erg is. It's not very complicated, but remember you are expected to know. And distance is measured in centimeters, and of course we are assuming that both of them are in the same direction, so cos 0 degrees will be equal to 1. Now when a force of 1 erg displaces an object by a distance of 1 centimeter in its own direction, then the work done will be equal to 1, what is that? Oh, yeah, sorry, dyne. Somebody mentioned this to me. Force is measured in dyne. Erg is the actual unit for work. Sorry. And therefore, the work done will be equal to 1 erg. Okay, did you catch that? I made an error. I put erg over here. Force is measured in dynes and displacement is measured in centimeters. If a force of one dyne displaces an object by a distance of 1 centimeter in its own direction, then the work done will be measured as 1 earth. Any questions?